Okay, this first question is a calculation. What's quite good here is they've given us this information to help us do the calculation. So the question says we've got this mass of copper sulfate and it was dissolved in 250 centimeters cubed. And it wants us to calculate the concentration. So according to this information here, the concentration is the mass divided by the volume. The mass is 3.14, but then we have to divide it by 250 because that's the volume. Now remember, this is centimeters cubed, so I have to divide that by 1,000 as well. So I'm going to plug that into my calculator. 3.14 divided by 250 divided by 1,000, and that is giving me an answer of 12.56, and that will be grams per decimeter cubed. Mark wise, we're going to get a mark in here for remembering this bit, and then a mark for the final answer. Sodium hydroxide is added to a solution of copper sulfate. Hopefully we're starting to remember some things about this. The copper sulfate here is a blue solution. A precipitate forms. Remember, a precipitate is a insoluble solid, so that means it doesn't dissolve. State what would be seen. There's only one mark, so you only have to put one thing down. First thing you could say is a solid would form, because this precipitate is insoluble and you start to see that form. The other thing you could say is the copper sulfate solution is blue, sodium sulfate solution is colorless, so we could also say the solution would go colorless, but you have to get one of them for the mark for that question. Okay, we could do this one just very quickly because we've got to balance the equation. This has got sodium in. Over here is sodium, and there are two sodiums here. So if I just put a big 2 in front, I'm going to have two sodiums there, and that will be correctly balanced. 1 mark for putting that in. Okay, next one. Describe how to get a dry sample of the precipitate copper hydroxide from the reaction mixture. So we just come back up here 1 second. The copper hydroxide, remember, that we're forming is insoluble. That's the precipitate. So basically, I have got a solution with this insoluble solid, this precipitate inside. I'm going to get that out and make sure that it is pure and make sure that it is dry. So in order to remove an insoluble solid from a solution, the method I would use is filtering, because the precipitate, being insoluble, would be trapped in here as the residue in the filter paper. So the first step is you would filter the solution. Once you've filtered it and you've got your precipitate out, you would rinse the precipitate that you've formed, and then the third thing you would do to get it to dry is leave in a warm place. There's going to be 1 mark for each of those points that I've listed. Okay, next one. We've got electrolysis here of sodium sulfate solution, and it says graphite electrodes are used because it's inert and conducts electricity. Figure 11 shows that there are sodium sulfate, the ions in sodium sulfate solution. Draw a circle around the ions that are attracted to the negative graphite. So if we're going to attract anything towards a negative electrode, then they have to be positive. So I'm going to have this one and this one are both going to be attracted to that electrode. So 1 mark if you got both of those right. State why it's important that the electrodes are inert. So what we've got to say here is so that they do not take part in the reaction. We don't want them to interfere. And explains in terms of the structure how graphite conducts electricity. So what we need to say here is that graphite contains delocalized electrons. You remember, graphite has carbon atoms. It should form 4 bonds, but it forms 3. And therefore it's got these delocalized electrons. And then what we need to say, which are free to move. And you're going to get 1 mark for each of those points in that answer.